Understanding Git, Git version, Git actions. A breakdown. Git, Git version, Git actions. Version management systems track changes to files over time. Enable collaboration and rollback to previous versions. This line introduces the concept of version control systems (VCS), of which Git is one. Version control system: a system that records changes to a file or set of files over time, allowing you to recall specific versions later. Git: a popular, free, and open-source VCS used for tracking changes in source code during software development. Tracking changes over time: every change you make to a file is recorded as a commit, which acts like a snapshot of the file at that moment. Collaboration: multiple people can work on the same project simultaneously, using Git to merge their changes efficiently. Rollback to previous versions: if you make a mistake or want to revert to an earlier state of your project, Git allows you to easily retrieve and restore past versions. Examples: you're working on a website and make a change that breaks the design. Git lets you revert to the previous working version. A team of developers are working on a software project. Git helps them coordinate their work, track changes, and resolve conflicts. Git, Git version, Git actions. Version management systems (USECSs). This line asks for examples of how Git is used in real-world situations. Examples: software development: Git is the standard for managing code in software development projects. Writing: writers can use Git to track different versions of their books or articles, collaborate with editors, and easily revert to previous drafts. Data science: Git can be used to manage code, data, and analysis results in data science projects. Git, Git version, Git actions. Version management systems inputs. This line asks for the data or information that is required by Git to function properly. Examples: files: Git requires the files you want to track. Commit messages: descriptive messages that explain what changes were made in each commit. Branch names: names for different lines of development within a project. Remote repositories: locations where Git stores a copy of your project's data. Git, Git version, Git actions. Version management systems outputs. This line asks for the results or information produced by Git. Examples: commit history: a record of all the changes made to the files in a project. Versions of files: Git allows you to access different versions of files at any time. Merge history: a record of how different branches were merged together. Diff output: a display showing the changes made between two versions of a file. Git, Git version, Git actions. Version management systems commands. This line asks for the instructions or actions you can perform using Git. Examples: Git init initializes a new Git repository. Git add stages changes to be included in the next commit. Git commit creates a snapshot of the current state of the repository. Git push sends local changes to a remote repository. Git pull fetches and merges changes from a remote repository. Git branch creates or manages branches. Git merge combines changes from different branches. Git, Git version, Git actions. Version management systems steps. This line asks for a sequence of actions or processes involved in using Git. Examples: creating a new project. 1. Initialize a repository: Git init. 2. Add files: Git add. 3. Commit changes: Git commit m initial commit. Working with branches. 1. Create a new branch: Git checkout b feature branch. 2. Make changes and commit: Git add. Git commit M added feature. 3. Switch back to the main branch Git checkout main. 4. Merge the feature branch Git merge feature branch. Git version, Git Actions version management systems challenges and fixes. This line asks for common problems that can occur when using Git and how to solve them. Examples: merge conflicts. When two people make changes to the same file, Git might not be able to automatically combine them. This is solved by manually merging the changes. Lost commits. Accidentally deleting a commit can happen. You can try to recover them using the git reflog command. Branch confusion. Keeping track of branches can be challenging. Use clear branch names and keep your branches organized. Remote repository issues. Problems with the remote server can occur. Try restarting the server or checking your internet connection. Git version, Git Actions USECSs. Software development. Git a version control system that tracks changes to code over time. It allows developers to collaborate on projects, revert to previous versions, and manage branches. Example: a team of developers working on a website uses Git to track all changes made to the code base. This allows them to see who made what changes, easily revert to previous versions, and collaborate on features without overwriting each other's work. Git version: a specific version of the Git software. Each version comes with its own features, bug fixes, and potential improvements. Example: a developer may use Git version 2.33, which includes a new feature for merging branches more efficiently. Git Actions: automated tasks that can be triggered by events in a Git repository. These actions can automate builds, deployments, testing, and other processes. Example: a Git action can be set up to automatically run tests whenever a developer pushes new code to the repository. Document collaboration. Git can be used to track changes to documents, ensuring a clear history of edits and allowing for collaboration between authors. Example: a team of writers working on a research paper can use Git to track changes to the document, allowing them to see who made what changes and easily revert to previous versions. Git version enables the team to work on different versions of the document simultaneously, merging changes later. Example: one writer could work on the introduction while another works on the results section, merging their changes later to create a complete document. Git Actions can be used to automate tasks like document formatting, spell checking, and generating PDF versions of the document. Example: a Git action can automatically convert the document to PDF and upload it to a shared storage location every time a new version is pushed. Configuration management. Git provides a reliable way to track changes to configuration files, enabling consistent setup across different environments. Example: a company uses Git to manage its infrastructure configuration files. This ensures that all servers have the same configuration, making it easier to maintain and troubleshoot. Git version allows the team to roll back changes to the configuration files if needed, ensuring a consistent state. Example: if a change to a configuration file causes a server to crash, the team can easily revert to the previous working version. Git Actions can be used to automate tasks like deploying configuration changes to different environments, ensuring a consistent setup. Example: a Git action can automatically deploy the new configuration to staging and production environments after a developer pushes changes to the configuration repository. Understanding Git version, Git Actions inputs. Let's break down each line. focusing on the role of Git Actions inputs within a GitHub workflow. 1. Git version, Git Actions inputs files. Git. This refers to the version control system itself, the foundation for tracking changes in code. Git version. This specifies a particular version of Git used for the workflow. It could be 2.35.1, for example, indicating a specific release of Git. Git Actions inputs. These are user-defined parameters that you can pass to your GitHub Actions workflow. They act as dynamic variables that control how your workflow behaves. Files. This refers to the specific files you choose to use as input for your actions. Example: you might have an action that analyzes code quality. You could define an input called files that lets you specify which files to check. YAML. Jobs. Build. Runs on Ubuntu latest. Steps. Name checkout code. Uses actions checkout 3. Name analyze code quality. Uses some user code quality action 1. With files src.js. In this example, the file's input is set to src.js, meaning the action will analyze all JavaScript files within the src directory. 2. Git version, Git Actions inputs commit messages. Git. The version control system. Git version. The specific version of Git used. Git Actions inputs user-defined parameters for your workflow. Commit messages. This refers to the commit messages associated with changes in your code repository. Example: you might have an action that checks if commit messages follow certain guidelines. You could define an input called commit messages that allows you to specify which commit messages to analyze. YAML. Jobs. Build. Runs on Ubuntu latest. Steps. Name checkout code. Uses actions checkout 3. Name check commit messages. Uses some user commit message checker 1. With commit messages head 5 head analyze last 5 commits. This example uses the input commit messages to define the range of commits head 5 head that the action should check. 3. Git version, Git Actions inputs branch names. Git. The version control system. Git version. The specific version of Git used. Git Actions inputs user-defined parameters for your workflow. Branch names. This refers to the names of branches within your repository. Example: you might have an action that deploys your application to a specific environment. You could define an input called branch name that allows you to specify which branch triggers the deployment. YAML. Jobs. Build. Runs on Ubuntu latest. Steps. Name checkout code. Uses actions checkout 3. Name deploy to staging. Uses some user deploy action 1. If github.ref refs head staging. With branch name staging. In this example, the branch name input is set to staging. The workflow will only deploy to staging if the current branch is actually staging. Key takeaway: Git Actions inputs provide powerful flexibility in controlling your workflows. They let you tailor the behavior of your actions based on specific parameters like files, commit messages, or branch names. Understanding Git version, Git Actions. 1. Git version, Git Actions outputs version history. Git. This refers to the version control system itself. It's the software that allows you to track changes in your code over time. Git version. This refers to the specific version of Git you're using. Each release of Git comes with new features and bug fixes. Git actions. These are the commands you use to interact with Git, like git add, git commit, git push, etc. Outputs. Version history. When you use Git actions, you create a record of every change you make. This history can be viewed through commands like git log, showing a timeline of commits, author information, and commit messages. Example: 1. Git using git init to initialize a new Git repository. 2. Git version. Running Git version to see which version of Git you have installed. 3. Git actions using git add, git commit, git push to stage, commit, and push your code to a remote repository. 4. Outputs. Version history. Viewing the history with git log to see the changes made over time. 2. Git version, git actions. Outputs. Diffs. Git same as above. Git version same as above. Git actions. Commands like git diff, git show, git log p are used to compare changes between versions of your code. Outputs. Diffs. This refers to the output of the above commands, which highlight the specific lines of code that have been added, removed, or modified between different versions. Example: 1. Git using git checkout to switch between branches or specific commits. 2. Git version same as above. 3. Git actions using git diff head to see the changes between the last two commits. 4. Outputs. Diffs. The command's output will show the code differences between the two commits. 3. Git version, git actions. Outputs. Merges. Git same as above. Git version same as above. Git actions. Commands like git merge, git rebase are used to combine changes from different branches or commits into a single branch. Outputs. Merges. The result of using these commands is the merging of changes, creating a new commit that combines the desired branches or commits. Example: 1. Git using git branch to create a new branch and git checkout to switch to it. 2. Git version same as above. 3. Git actions using git merge branch name to merge a branch into your current branch. 4. Outputs. Merges. The command's output will show the merge process, including potential conflicts that need to be resolved, and the final merged commit. Understanding Git commands. 1. Git version, git actions. Commands add. Git. This is the core version control system. It's a tool for tracking changes in your code. Git version. This command tells you which version of Git you're using. For example, git version could output git version 2.34.1. Git actions. These are the commands you use to interact with Git. Commands add. The git add command is used to stage changes in your files. This means you're telling Git that you want to include these changes in your next commit. Example: git add. This adds all changes in the current directory to the staging area. 2. Git version, git actions. Commands commit. Git as before, this refers to the version control system. Git version, the version of Git you're using. Git actions. Commands to work with Git. Commands commit. The git commit command creates a snapshot of your project at a specific point in time. It's like taking a picture of your code's current state. Example: git commit m fixed a bug in the login function. This commits the staged changes with a message describing what was changed. 3. Git version, git actions. Commands push. Git version control system. Git version information. Git actions within Git. Commands push. The git push command uploads your local commits to a remote repository, e.g., GitHub. It's like sharing your changes with others. Example: git push origin main. This pushes your local commits to the main branch of the origin remote repository. For git version, git actions commands pull. Git version control system. Git version information. Git actions within git. Commands pull. The git pull command fetches changes from a remote repository and merges them into your local branch. It's like getting updates from others. Example: git pull origin main. This fetches and merges changes from the main branch of the origin remote repository. 5. Git version, git actions commands branch. Git version control system. Git version information. Git actions within git. Commands branch. The git branch command is used to manage branches in your repository. You can create new branches, list existing branches, switch between branches, and more. Example: git branch feature renew feature. This creates a new branch called feature renew feature. 6. Git version, git actions commands merge. Git version control system. Git version information. Git actions within git. Commands merge. The git merge command combines changes from one branch into another. It's like merging two separate timelines. Example: git checkout main git merge feature renew feature. This switches to the main branch and merges the changes from the feature renew feature branch into it. Git version, git actions. 1. Initialize repository. Git. This refers to the version control system itself. It's a powerful tool for tracking changes in files over time, allowing you to collaborate with others effectively. Git version. This refers to the specific version of the Git software you are using. For example, Git 2.36.1 or Git 2.37.0. Git actions. These are specific commands or operations you perform within Git. Steps 1. Initialize repository. This is the first step in using Git for a project. It creates a new Git repository in your chosen directory. Example: bash git init. This command will create a hidden .git folder within your project directory, which stores all the Git metadata and history. 2. Add files. Git. Still the version control system itself. Git version same as above, specific version of Git. Git actions. The specific operations you perform within Git. Steps 2. Add files. This step tells Git which files you want to be tracked within your repository. Example: bash git add. This command adds all files in the current directory and its subdirectories to the staging area. Alternatively, you can add specific files. Bash git add readme.md. 3. Commit changes. Git. The version control system. Git version. The specific version of the Git software. Git actions. Specific commands used within Git. Steps 3. Commit changes. This step saves a snapshot of your current changes to the project's history. It's like taking a picture of the project at a specific moment. Example: bash git commit m initial commit. This command creates a commit with the message initial commit that includes all the files you added in the previous step. 4. Push to remote. Git. The version control system. Git version. The specific version of the Git software. Git actions the specific commands used within Git. Steps 4. Push to remote. This step uploads your committed changes to a remote repository, usually hosted on a service like GitHub, GitLab, or Bitbucket. This allows you to share your project with others and collaborate. Example: bash git push origin main. This command pushes the local changes to the main branch on the remote repository named origin. Understanding Git challenges and fixes. Here's a breakdown of common Git challenges and how to solve them. 1. Merge conflicts. Challenge: when merging branches, Git might encounter conflicting changes made in both branches. Fix: use Git merge tool to resolve conflicts. This tool provides a visual interface where you can compare the conflicting changes and choose the desired outcome. Example: imagine you're working on a feature branch and another developer makes changes to the same file. When you merge your branch back to the main branch, Git detects conflicting edits. You can then use Git merge tool to review the conflicting lines and decide which version to keep. 2. Lost changes. Challenge: accidental deletion of commits or files can lead to lost work. Fix: use Git reflog to recover lost changes. This command displays a record of all operations performed on the repository, including discarded commits. Example: you accidentally deleted a commit containing important bug fixes. Using Git reflog, you can find the commit's unique ID and restore it to your branch. 3. Branching issues. Challenge: managing multiple branches can become challenging, leading to errors like accidentally committing to the wrong branch. Fix: use Git branch and Git checkout to manage branches effectively. Git branch lists available branches, while Git checkout switches between them. Example: you're working on a new feature and accidentally committed changes to the main branch. Git checkout feature branch switches back to the correct branch, preventing accidental pushes to the wrong location. 4. Remote synchronization. Challenge: keeping your local repository up to date with remote changes can be tricky. Fix: use Git pull to download changes from the remote repository and merge them into your local branch. Example: another developer has pushed new features to the remote repository. Git pull ensures your local copy is updated with their changes before you start working. 5. History management. Challenge: managing the history of your repository effectively is crucial for tracking changes and reverting to specific states. Fix: use Git log and Git revert to manage the history. Git log displays the commit history, while Git revert creates a new commit that undoes a specific commit without rewriting history. Example: you realize a recent commit introduced a bug. Git log helps you identify the problematic commit. Then, Git revert commit ID creates a new commit that reverts the changes, allowing you to fix the issue without altering past commits.